Okay, let's continue with the topic of DML, better known as the data manipulation language. All right, so DML is the mechanism by which we can insert, update, delete, or undelete records within the Salesforce database, okay? In fact, there's actually a few other options. There are things like merge, which works with records where there's a winner record identified and a loser record. And what it does is it does things like copy over the non-null fields from the loser over to the null fields of the winner. It updates the winner, and then it deletes the loser record. There's things like an upsert, which is a combination of an update and an insert. You use these things called external IDs. And if we find a single record with a value for that external ID field, we perform an update to the record. If not, we perform an insert. So it essentially has that logic to handle that. But for the most part, you're going to be working with inserts, updates, and deletes. Those are the most common types of operations that you'll be performing. When we are modifying the database, we can supply either a single record, a single S object, or a list of S objects. So let's take a look at the syntax that we would use within Apex in order to accomplish this. On line 2A, we have insert account, and so we can use a set of keywords to perform these different types of operations. Now, on line 2B is a method, database.insert an account. So we can also use this database class with the insert method to do the same thing. Now, in a second, I'm going to explain to you what's the difference between these two. But both of them work with both a single S object, or like we have here, it can work with a list of S objects. All right, so when we have a list of S objects, so in this case we're inserting a list of accounts, in this case only 3 accounts, the behavior is if one fails, then all fail, okay? So if I let's say I have an account and I'm missing a required field on one of the records, if one of them fails, then none of them will be written to the database. In fact, what this is going to do is, because this assumes that all of the data is good, in this case we're going to be throwing a DML exception. You'll have to handle the DML exception that you get back. Now there's also the method form. And what the method does is it gives us the ability, there is a overloaded second parameter, which is the all or nothing flag. And what this is this is a Boolean where you can say, I don't want you to enforce that rule of all or nothing equals true. So this gives you the ability, so if one record fails, well, that's fine. Let's write the other 2 records to the database. Okay, so one fails. All right. Now, because you're doing this with the assumption that these might fail, the behavior is different. In this case, it's not going to throw a DML exception. What it's going to do is it's going to return something called a list of save results. So the save result is an object that you're going to get back where you can inquire about which records succeeded, which records failed, and then why did those records fail when you're attempting to write them to the database. Okay. So here we have whether you're doing an operation on a single record or a list of records. In this case, if we're working with a list, we're going to get back a list of save results. What you're going to do is when you get back your list of save results, there is an is success flag. And then if it did not succeed, you can access the errors associated with that record. Okay. There's also database.dml options. And what this does is database.dml options allows you to control some of the behavior of the DML operation that you're performing. So a classic one is truncation. In a field of type text, you can set a maximum length. So if I have a string and the string contains 10 characters, but I have a field with a maximum length of 5 characters, well, what do I want the database to do if I attempt to write those 10 characters to that field on that record? You have two options. By default, it's going to throw an error, or you can allow truncation. And so you can just say, I'm going to take the first 5 characters and chop off the last 5 characters and successfully write those first 5 to the database. All right? So there's a number of other things that you can do, things associated with CRM. So do you want to fire off assignment rules? If you've ever created a case, you'll notice at the very bottom there's that checkbox. Do you want to apply the assignment rules in terms of ownership? So in the same way here, you can turn that flag on or off. All right, I want to jump ahead to a slide up here that, to me, explains a relatively simple concept, and then we'll jump back to the next slide. What this concept is that you cannot do an insert on a record that contains an ID. Okay? So if you're going to be doing an insert, you cannot have an ID. And then our updates work by having records with IDs, and that's how we locate them. If you have an external ID, which we'll talk about in the next or the previous slide, we can deal with that too. So we'll cover the upsert in a second. So let me walk you through some code and just talk about some of the behavior that exists when we're working with DML. So here we have an account, and on line 1, we simply create a record in memory. In line 2, we're now going to insert that record into the database, so it now exists in the database. One of the key things that happens anytime you do an insert is that when you do an insert, we will return the ID of that record. So after line 2, A now has a populated ID field. Okay? By the way, the database always sets IDs. You do not have the power to define your own IDs. Okay? They're always database generated. So our account A now has a populated ID field from the database. Now in line 3, we're going to create a contact record. So once again, this exists only in memory. On line 4, what we do is we associate this contact with this account. So we're going to set our account ID field on the contact equal to the generated ID on the account. And then on line 5, we are going to insert our new contact. So now we have a contact associated with the account. On line 6, we're just going to reconstitute the contact record, but by default, in this case, we populated the account ID field. Remember that the account ID field in our relationship fields is equivalent to the _C field, and the account field is equivalent to the _R field. Right now, so at the end of line 5, after line 5 is completed, account, C.account has not been populated. Okay? Only account ID has been populated. In order to instantiate C.account, we could do one of two things. We could say C.account equals A, or we could fetch it from the database like we're doing here. So in this case, we're overriding the contact and making sure that we supply a value for the account field by selecting account.name. All right? So here we have select account.name from contact with the same contact record ID. So now C has a populated account field. In line 8, we are then going to do C.account.name, and we are going to be making a modification to our account record in memory. On line 9, we're going to make a modification to our contact record, specifically that last name. When we execute line 10 and we say update C, this is only making a modification to the contact record. the account record in the database is unchanged. So if we want to make a modification to this record that now has Salesforce as its name, we must do update on c.account. Okay? All right, let's talk about the concept of external IDs. We can associate records not only using the Salesforce IDs, but we can also associate them using what we call external IDs. And so the idea behind an external ID is that it's a custom field on a object, and what we're going to do is we're going to store a key from some other system. So for instance, let's say we have an SAP system, which is our ERP system. If we have our accounts being kept within that ERP system, we can take those IDs from that system, load them into Salesforce, and use those to identify those records within our database. All right, so in this case, our custom field is called external ID, and it's on the account object. So here we have our new account. We're going to instantiate a contact. We can then do an insert of C, and what it's going to do is, based on the existence of this populated external ID field, it's going to go out and look for a record where the account's external ID equals 1, 2, 3, 4, 5. The way that this works is that if it finds a single account record with this value for this external ID, then it's going to successfully associate this contact with that account. If it finds 0 accounts, or if it finds multiple accounts with this value for this external ID, it's going to result in an error. Okay? Here we have our second example, and this is really what's going on behind the scenes. So in other words, you don't have to do what's being shown here in this second example. You don't have to fetch the Salesforce ID from the database and then use that to perform the correlation. But roughly, this is kind of what's going on behind the scenes. So line 1B is really unnecessary from your standpoint. You don't need to do that. DML and loops. So once again, we talked about that death by 1,000 paper cuts type of situation. When we are performing DML operations, you should identify all of the records that you want to update or insert into the database, create a list, and then insert those or update those. What you should not do is what we're showing you right here. You should not create a loop and then inside of there perform a single update, one record at a time. All right? And the reason is we're making multiple round trips, and if we have many records, we're going to consume our database connections. The better way to do it is this. What we're doing is we have a list of records. We're going to iterate over those records that we get back from the database, and then we're going to use that list to perform the update. That way we're doing a single call out to the external database, and then we're making that change in one bulk operation. If you happen to be using our for loop with the SOQL query, this is an okay thing to do. The one situation where it's okay to place a DML operation, or for that matter a SOQL query, inside of a loop is where we are operating on that 200 records at a time. In this case, if you're updating every single record, you're getting back your result. This position list is a list of 200 records, which is also the size of ultimately, how we're going to be chunking up our DML operations. So we already know that this one has been bulkified. In general, SOQL and DML with respect to governors, if you're exceeding the total number of SOQL queries, take a look at your loops. So that's the number one problem that we see. If you're exceeding the total number of executed script statements allowed, reduce the number of loops or recursion. There's kind of a trade-off that always exists between, if you can possibly perform, for instance, filter out the records that you're seeking with a more complicated database query, as opposed to running that within, or filtering out the records that you get back within your code by examining them. If you're exceeding the total number of DML statements, once again, insert, update, or delete in bulk. And then if you're getting back too many records, make sure you use that limit, apply that limit to the query, and then just inform your end user that there might be more records out there. All right, let's talk about the transactional nature of doing DML. So we've already talked about when we're working with a list of S objects, we have the all or none flag where we can control the transactional nature of that single DML operation of the list of records. In addition, the context of our transaction running within Apex, if we have an uncaught exception anywhere within that transaction, everything will get rolled back. Okay, so once again, if you have that controller which performs that DML operation, which fires off a trigger, all of this is a single transaction, and if we have that uncaught exception anywhere during the execution of that, we're simply going to roll it back. Okay? Now we can control that using save points. And what save points give us the ability to do is they give us the ability to identify our own transactional boundaries within our code. And so let's take a look at the way that this works. What you would do is there is a set save point method associated with the database class. We can set up our save point. What we get back is a save point object itself. If we wanted to, we could then use that later on to roll back all the operations that have occurred in the interim. So in this case, here I would set my save point and then perform some DML operations, and based on the success or failure of those, either commit those or not commit them necessarily, but don't roll them back. And then here we see on line 12, you would use that reference that you had to that save point if you wanted to roll back those operations that have occurred in between the setting of the save point and the call to the rollback method. Now, one of the things that's important to understand about Apex is that although you have the capability and the power to do your own explicit rollback, you do not have the ability to do an explicit commit. The commit occurs implicitly at the end of the running of the transaction. Okay? So assuming we get to the end of the transaction and assuming that we didn't have any uncaught exceptions or exceed any governors, the engine will then implicitly commit those records to the database. Okay, all right. So what is an S object? What is an S object in Apex? What does it represent at the end of the day? What does a single S object represent? Yeah, so it's a record in our database. And it can be either a standard or a custom object. Okay? When we think about how S-object relationships are named when it comes to custom relationships, what are the 3 fields that we have available when working with custom relationships in Apex or SOCL for that matter? We have 3 fields which are available. On the child, there are 2 fields, and those 2 fields are the R,
which is the relationship.
The relationship to the parent.
Which is the reference to the object reference to the parent.
Exactly.
Key is the ID.
Exactly. So the _R contains the object-oriented reference to the parent. The _C is going to contain that ID. And then what is from the parent down to the children, we have another field. And what is that field?
It should just be the object reference.
Uh-huh.
So it should just be _C.
Nope. So when we're on the parent, we have the _R, but the key thing about that is that it's a plural. So from the position, in our case, we have job applications _R, which is a reference down to those children. Okay? Object-oriented reference to the list. What is the difference, the key difference between the standalone DML statement and the database methods? They both are going to modify data in the database. What's the key difference? What's the one thing that separates the two?
Database gives you a couple of more options.
And what is those? What are those?
All or nothing.
That's the key option. So it gives you the all or nothing. So you can set all or nothing equal to false in the case of the method format. Okay, very good. How should DML be used within loops? What else about that list? So if we think, let me put it this way. Let me try and rephrase this question. I would say the answer to this one is, how should DML be used within loops? The answer would be carefully. What's the one situation where I said it's okay to put DML inside of a loop? There's a specific sort of feature or syntax that I'm referring to. Yeah, so we're working with S objects, and it's doing something specifically. It's a specific type of loop. It's the kind of loop where we have, so there are 3 different types of loops for the most part. One is the old school for loop. There's the for loop, which is a for each statement. And then there's the variation associated with sockle. So in the variation with sockle, if we have a list that we're getting back from our query, then we can do DML. But for the most part, you should avoid it. Okay? All right. What are the 2 ways to insert sockle into Apex? What are the 2 ways to write sockle queries?
That would be a mirrored SOQL in the export. That's one option.
What's the option? The
A mirrored SOQL in the export.
yeah. So how would we surround your sockle query with?
Oh, the square bracket.
Square bracket. So we can do the square bracket sort of inline query. And then the second type of query we can run is a yeah.
Using database query.
Yeah, so we have the method. So we can use a string, so we can dynamically generate a string-based query and then execute it using the database.query method. Okay? What are the 4 return types returned from sockle?
Single object.
Mm-hmm.
A list.
Be more specific. So a single S object,
Okay. A list of S objects.
a list of concrete S objects.
Oh, yeah.
Very good. Got 2 of them.
An integer.
An integer if we do a select count. Very good.
And where you do the group by or with the functions.
The aggregate functions.
Aggregate functions.
Yeah, so what we get back, does anyone know the name of that class? Aggregate results. So we get back a list of aggregate results if we perform or if we calculate things like subtotals. Okay? So single S object, single concrete S object, list of concrete S objects, and then list of aggregate results, and then a integer in the case of doing a count. Okay? What are the advantages of using sockle for loop? This is kind of a tough one. What is the key advantage of using that sockle for loop? So the for loop with the sockle that we're iterating over, the results that we're iterating over. The more efficient exactly. So when we're doing the sockle for loop, one of the key advantages is that we're getting back our results 200 at a time. And so the amount of heap space is limited to those 200 records at a time. The only caveat being if you maintain a reference to those objects, then we keep them on the heap. Otherwise, it automatically cleans up the heap space of the records that you don't use. Okay? When should you use sossle versus sockle?
Sossle is to do full text search.
Yeah. Exactly. So when you need to search across multiple fields on multiple objects, searching for keywords, that's the key advantage of sossle. Very good.